Welcome to The Explainer. Today, we are diving into a really revolutionary piece of technology. It's something designed to protect our cities from the sky, but not in the way you might think. We're talking about an invisible shield, basically a passive nervous system for an entire urban area. This is the RAPS dome. All right, so here's how we're going to break it all down. First, we'll look at the problem it was designed to solve. Then, we'll get into the elegant solution itself, the RAPS dome. After that, we're going to pop the hood and see how its sensors and its brain actually work. Then we'll look at how this thing is being brought to life. And finally, and this is the really cool part, we'll discover its incredible potential that goes way beyond just security. So, first up, Section 1, a new urban threat. Look, before we can really appreciate just how brilliant the solution is, we have to get a handle on the problem, a challenge that's quietly emerging from our silent skies. I mean, really think about that for a second. The skies above our cities, they're getting crowded. We've got small, fast, and potentially pretty dangerous drones flying around. They're hard to see, even harder to hear, and they create this totally unique challenge for protecting our cities and all the critical stuff inside them. And here's the thing. Our old ways of detecting threats, they just don't cut it anymore. Traditional radar gets completely confused by the concrete canyons of our cities. You know, all the tall buildings create blind spots. And other systems, like acoustic or optical ones, are just drowned out by the constant noise of city life. So we don't just need a better sensor, we need a fundamentally new way of sensing altogether. Okay, so that brings us to the big idea, the next generation solution. This is Section 2, the RAPS dome shield. And that word right there, passive, that is everything. This system isn't shooting out signals like radar. No. Instead, it's more like a city-wide nervous system. It creates this invisible shield that can literally feel the tiny disturbances in the air above us with just incredible precision. So this slide here really gets to the heart of what makes the RAPS dome so powerful. First, it's proactive. It catches threats early. It's incredibly precise, sensing things that radar is completely blind to. It's intelligent, which means it avoids all those annoying false alarms that drive operators crazy. It's scalable, so you can start with one spot and grow it to cover an entire city. And, crucially, because it's passive, it works in total silence, without messing with our Wi-Fi or cell signals. So the big question is, how does this invisible shield actually work? Well, that brings us right to Section 3, a symphony of sensors. Okay, this starts with an absolute stroke of genius, using the stuff we already have. The system literally turns the thousands of miles of fiber optic cables buried under our feet into a massive web of virtual microphones. This tech is called Distributed Acoustic Sensing, or DAS, and it can pick up the super faint vibrations in the ground caused by a drone flying low overhead. It turns our telecom network into a giant sensor. How cool is that? And if that wasn't sensitive enough, get this. The RAPS dome also uses these laser interferometers that are so unbelievably precise, they can feel the tiny shifts in air pressure from a drone's spinning rotors hundreds of meters away. And by putting these lasers in sealed tubes, the system stays that sensitive even with all the wind and turbulence you get in a city. But here's the magic. No single sensor does it all. The real power is in combining them into what the creators call a symphony of data. You've got the fiber optics, the lasers, microphones, cameras, even radio frequency detectors. Each one is like a different instrument in the orchestra, providing a different piece of the puzzle. And they are all timed together perfectly, down to the millisecond, to create this rich, multi-layered picture of what's happening in the sky. But you know, just sensing stuff is only half the battle. The real game changer is how the system thinks. Welcome to Section 4, the Bayesian Decision Engine. This is the secret sauce of the RAPS dome. This right here is what makes the RAPS dome so much more than just a pile of cool sensors. This is the brain of the operation, the RAPS engine. It's the intelligent core that takes all that messy, raw data from that symphony of sensors and turns it into clear, simple, actionable decisions. And it does it by following this really smart four-step process. First, it fuses all the data from all the different sensors. Then, and this is the absolutely critical part, the Bayesian layer. It doesn't just look for a simple trigger. It calculates the actual mathematical probability that something is a threat. Step 3, it turns that probability into a simple risk score. And finally, Step 4, it gives a clear, unambiguous decision, accept or reject. It gives operators a verdict, not just more data to sort through. And this comparison just lays it all out. Old systems, they drive people crazy with false alarms. A bird flies by, a plastic bag floats in the wind, and suddenly alarms are blaring. It leads to what's called alert fatigue. The RAPS engine, on the other hand, is built for fewer than one false alarm a day. Why? Because it demands that a potential threat be seen by multiple different types of sensors before it takes it seriously. That is absolutely critical for an operator to trust the system. Okay, so this all sounds incredible on paper, but is it just a theory? Let's get practical. Let's move to Section 5 and see how this amazing concept is actually being turned from a blueprint into reality. And this isn't just wishful thinking. The whole project is driven by these really impressive and specific performance targets. They're aiming for at least a 90% chance of detecting any threat. They're sticking to that insane goal of less than one false alarm per day. A decision has to be made in under 5 seconds. And they need to pinpoint a threat's location to within 200 meters. These aren't just goals, they're the benchmarks that prove the system actually works in the real world. And they have a clear plan to get there. You can see it's a very logical, phased roadmap. They start with the boring but necessary legal and technical assessments, then they deploy a single pilot node to prove it works. After that, they expand to a small network to get the triangulation just right, and finally, they scale up to cover an entire city, all within about a year and a half. Okay, so now for my favorite part. Let's expand our thinking a bit, because the RAPS Dome is so much more than just a security system. This is Section 6, Beyond Security, a new science. And this is what makes the technology truly paradigm-shifting. Once that shield is up and running for security, it basically becomes this multi-purpose urban observatory. Those same super-sensitive sensors, they can monitor for tiny earthquakes, track the sound of an approaching storm, and even follow bird migration patterns right through the city. It turns a defense system into an unbelievable dual-use tool for science and for ecology. And if we look even further down the road, the whole system is built for what's coming next in artificial intelligence. Its architecture is designed to work with advanced AI theories like helix light vortex and ALE. Now, these are frameworks for creating hyper-efficient AIs that learn from complex resonant patterns, which is exactly the kind of beautiful data that the RAPS Dome symphony of sensors will create. It's basically the perfect physical nervous system to bring these next-generation AIs into the real world. And all of this brilliant design leaves us with one final fascinating thought. We started this whole explainer by asking how you defend a city from threats you can't see. But the RAPS Dome shows us we can do so much more. We can literally give our cities a nervous system, a set of senses. And so the real question becomes, once our cities can feel and listen and see in ways they never could before, what on earth will they tell us about themselves and about the world we all live in?